Hello everyone, let's discuss doses calculation. Let's first calculate the loading dose, which is the initial dose that we give to the patient. So we have first the plasma concentration, the desired concentration, the concentration I want the drug to be in the blood. For example, my drug needs to be 10 units per liter for it to be effective. And we have another concept, which is volume of distribution, which is a theoretical concept that explained at another video, which means the total theoretical size a drug will be distributed to after I give it to the patient. And the third concept, which is the bioavailability, which presents the portion of a drug that will pass the absorption, will pass the metabolism, will pass the absorption and then pass the metabolism and then reach systemic circulation. So for example, I give 100 units, only 80% units passed these barriers. So the dose that I will give to the patient will be equal to the desired concentration of the drug in the plasma multiplied by the volume of distribution. So for example, I want this drug to end up in a concentration at plasma which is 10 units per liter. How much I should give him? I need to know how much liters my substance will end up in. Let's say my substance will end up in 10 liters. That is my volume of distribution. Any amount I give, 1 unit, 2 units, 100 units, they will all reach 10 liters in the body. So if I want to reach 10 units per liter, I want each liter to have 10 units, and the drug will reach 100 units. I need to give him, and the drug will end up at 10 liter, not 100 liter, 10 liter. I need to give him 100 units, so that each one of these 10 liters will end up with 10 units. So the amount of drug I need to deliver is equal to volume of distribution multiplied by drug concentration. And since we mentioned the bioavailability, the percentage of drug that will pass these barriers, the barrier of absorption, the barrier of metabolism. So let's say 80% of the drug will pass. I need to raise this amount by the equivalent of 80%, dividing it by the bioavailability. Not raise it by 80%, but divide it by the bioavailability to encounter for the loss of drug. So I need to deliver to the systemic circulation what is equivalent to the liters, the volume of distribution, the liters my drug will be delivered multiplied by the concentration of that drug, and this number we need to count the bioavailability in this process. This is the loading dose. What's about the maintenance? I don't know how to write this correctly. So, because I'm very tired and sleepy, we need to calculate the loss, how much drug we would lose. So the concept that we need to deal with is the clearance, which is the volume, not amount of plasma that is cleared from a drug per unit time. That's how we measure excretion of a drug, by the volume of blood that is cleared. We also need the time, because definitely in a certain drug, if we give it one every 12 hours, we will give more of that drug if we want to give it once every 6 hours, because here we have more time to lose. So we need the time, the interval between each time we give this drug. We definitely need the plasma concentration, of the wanted drug. If I want to keep a drug at a high rate, definitely I will need different maintenance dose than if I want to keep it at a lower rate, and we would also need our old bioavailability point. So the maintenance equation, first I need to figure out what is the amount of blood, the amount of drug that is lost. So I need to convert the clearance, which is in liter, which is a volume in liters, to something else, to amounts in my units of measuring the amount of drug. So what I will do, I have my clearance, I will multiply it by the time, because it is per time unit, and I will multiply this by the desired concentration. So when I first multiply the clearance per time, now I have the total amounts of liters that were cleared. So I left my patient for 6 hours without taking the pills. His body cleared 12 liters. I left my patient for 12 hours without the pills. His body cleared 24 liters of blood, of a fluid, not blood. His body cleared 24 liters. By multiplying the clearance by the time, I have the liters of fluid that were cleared. By multiplying this number by the initial concentration of a drug, I have the amount. The concentration is, for example, 1 unit per liter. Since my body cleared 12 liter, so I need to replace it by 12 units. Now, what should I give to replace 12 units? Is 12 units over the bioavailability, to take the bioavailability in perspective. So we have the maintenance dose, the clearance, multiplied by time, to get the volume of fluid that was cleared, multiplied by the dose, to get the amount of fluid that was cleared, hence getting the amount of fluid that need to be replaced, and divide this by the bioavailability to take in counter, so I know the amount of fluid I need to give the patient to deliver the loss. So maintenance and loading dose calculation. But also we need to mention that when we speak about maintenance, if the patient suffer from renal problem, hepatic problem, it is decreased. Maintenance is not changed in this condition. Maintenance is decreased, loading is not changed. Maintenance is decreased, loading is not changed in case of renal and hepatic problem. I'm studying for step 1. All of this information were mentioned at a very small box at first aid, which is a very great book. I wish I discovered that book back when I was college student.